Hi everyone, welcome to the video. We are going to solve largest subsquare surrounded by x. In this question, we are given a matrix of range n cross n, and we have to find the largest square, side of largest square, which can be found inside this matrix, beside the condition that the boundary or the sides of that square matrix will be x and not o. So this matrix will have two elements, x and o. Okay, and we need to find the maximum length square submatrix in which the boundary values will be x. Inside it can be 0 also, o also. See in example 1, you are given a matrix of 2 cross 2, and all the elements, since all the elements are x only and they form a square themselves, hence our answer will be 2. But example 2 will give you better understanding. See, the matrix is of n cross n, which is 4 cross 4. Cool, it is square matrix. If you consider the first three columns in row 1, first three columns in row 1 as a boundary value, they are x, you can take it. Then the next three value in column 2, x, o, x. Okay, the boundary values are x. Middle value can be anything. Middle value can be x or o, either of them. All the boundary values, okay, the surrounding values should be x. Yes, we can take this also. Again, if you come to the third row, okay, third row and the first three columns, then again they are x. So if you take this submatrix with the first row, first three columns, second row, first three columns, and third row, first three columns, then they form a submatrix of range and 3 cross 3. And apart from that, all the boundary values are x. Middle value can be anything. There is one possibility of middle value, and it is o, and that is permissible since we only need to care about the boundary values and not the middle values. Cool, if you can see over here. Fine, we'll do it. We'll do this question using DP. Okay, so first of all, I will store the number of rows and number of columns. Okay, so length of A will give number of rows and length of A0 will give you number of column since it is square matrix. Then I will form a DP. Okay, I will form a three-dimensional DP. Okay, and fill it with completely 0. Size row plus 1 and column plus 1. Okay. I have initialized this three-dimensional DP with 0 and DP I0J. If you can see IJ 0 or IJ1. Okay. Now there will be two values IJ0. Okay, IJ and this first value. Okay, first cell, then IJ0 will represent the length of consecutive axis horizontally, and this second one, the second column, which is the one inside it. So ij1 will represent the length of consecutive axis vertically, ending at this current position. Cool. Now we will fill this DP. Okay, with the probable candidates. Take all the rows, all the columns. Cool. First thing we'll do is we'll check if this particular cell value, is x or not. That is what we need to take care of. Okay. If this particular cell value is x, then there will be two conditions. We'll update the cell values of the DP. Okay, then I plus 1, j plus 1, and 0. Similarly, there will be one more cell. I will fill it, but I'm just telling you the cell values. Okay, and 1. There are two values. As I told, this cell value ij and 0 will represent the horizontal length, and ij1 will represent the vertical length. Cool. Now this I plus 1 j plus 1 0, okay, will be one more than length of consecutive axis horizontally ending at this cell value ij. Length of consecutive axis which are ending at this cell value, okay, which is dp I j plus 1 and 0, I j plus 1 and 0, okay. So this is the length of consecutive axis ending horizontally, consecutive axis horizontally ending at this cell ij. Cool. And one more than that. Then again, for this vertical, we'll do the same thing. Number of consecutive axes ending vertically at this position to be I plus 1, j and 1. And one more than that. Cool. In this manner, we fill the entire DP. I will again iterate these two. These are two very crucial steps. Okay. So ij 0, since ij 0 take care of horizontal length. So it will be one more than length of consecutive axis horizontally ending at cell value ij. And this I, j and 1, this since it is concerned with the vertical length, so this I, j and 1, I plus 1, j plus 1 and 1 will hold the length one more than length of consecutive axis vertically ending at this cell value ij. Cool. I will create a variable mx to 0 which will hold the length of the largest square submatrix, okay, which will be formed, and we will alter it. So first of all, I will traverse in this matrix starting from last to end. Now we will iterate backwards over the rows and columns of this matrix. I will create another variable mn, okay, out of the which will hold the minimum value of this horizontal length and vertical length, minimum of this horizontal length and vertical length. Cool. Which will represent the potential length of a particular side of square submatrix, which ends at this current index, which is I and j, current cell I and j. Fine. Now we will check if this minimum value is greater than the maximum, okay, and maximum will be our answer at the end. And minimum is this current value, okay, mn is current value. You can name it current also. Cool. Now while this minimum is greater than the maximum value, which will be our answer, we will check if a square submatrix of side of length minimum can be formed or not. If a square submatrix of side this mn length can be formed or not. We will check if the top right corner has a vertical streak of x of at least current mn. Okay, how will do it? If top right corner, how will do it? dp I minus mn plus 1, then j and then 1. If this top right corner has length greater than or equal to mn, then take it. Again, if the bottom left corner, okay, if the bottom left corner, which is again dpi j minus minimum plus 1 and then 0 greater than or equal to mn. What are we doing over here is, first I am checking if the top right corner, okay, if the top right corner has a vertical streak of x at least mn or more than that. Then I'm checking if the bottom left corner, this represents the bottom left corner, has a horizontal streak of length at least mn, at least of length mn or more than that. If both conditions are met, we'll update the maxi mx maximum length to this minimum value, which is current value so far. But if either of the condition fails, this will not go inside the if condition, and in this case we will have to minimize this minimum value. We will decrement this minimum value, and we will come out of the loop when we go out of the bound, and by that time we will have found the length of maximum side of length. Okay, maximum length of side of maximum square matrix. By that time we will return our result with the value mx, and this must do our job. Let's see. Okay, what is the issue over here? Okay, no. Okay, this is the issue. We're showing somewhere else, but that was the case. Yeah, you can see it is doing the job since we have applied the correct logic. Although this solution may get uh, overhead complexity, more complexity, but it is very naive and will do the job, and it is pretty easy to understand also. See, it took more time since we are employing lot of complications. Okay, we are using matrix, we are using dp, we are using, okay, we are traversing through entire rows and columns, and we are doing multiple calculations over and over again. That is why it took more time, but it is pretty straightforward and very easy to understand. Okay, so I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.